Hi everyone, today we are going to study Hamiltonian graphs. But before we study Hamiltonian graphs, we must know what Hamiltonian paths and Hamiltonian circuits are. So, we will start with Hamiltonian path. A Hamiltonian path starts at one vertex and ends at a different vertex, and the path must travel through all of the vertices once. So very clear and simple rules that as it says that the path starts at one vertex and ends at a different vertex. That means it clearly says that if you are looking for a Hamiltonian path, the initial and final vertices, which you also call the terminal vertices, must be different. Such a path which has different starting vertex and different ending vertex can be thought of as having a Hamiltonian path. So the first condition is different terminal vertices. Then the second condition is that the path must travel through all of the vertices once. That means the path should contain a walk which traverses all the vertices of the graph once. No vertex is traveled more than once, and all the vertices are traveled in the graph. You cannot leave any vertex, nor can you travel and traverse any vertex more than once. However, not all of the edges need to be used when creating a path. So this compulsion that all the vertices of the graph must be visited does not apply on the edges of the graph. So it is not compulsory to visit all the edges of the graph, but it is compulsory to visit all the vertices of the graph, and it is also compulsory that those vertices are not visited more than once, and the walk should not have the starting and ending vertex as the same vertex. The starting vertex and ending vertex must be different. So such a walk is said to or is called a Hamiltonian path, right? So the three important points: first of all, that the starting and ending vertex must be different. Then the path or the walk must visit all the vertices of the graph, and no vertex must be visited more than once. And the third point, that this compulsion is not for the edges. You do not need to visit all the edges of the graph. Now let's find out a Hamiltonian path in this graph. You can see this is a graph containing how many vertices? 1, 2, 3, 4, 5. So this graph contains 5 vertices, and how many edges? 1, 2, 3, 4, 5, 6. So total we have 5 vertices and we have 6 edges. So the number of vertices is 5 over here, and the number of edges is 1, 2, 3, 4, 5 and 6. The number of edges is 6 here. So the first rule of the Hamiltonian path, if I try to find out a Hamiltonian path, let's start by having a walk which starts from the vertex A. So it starts from the vertex A. You start from vertex A, then you reach vertex B. From vertex B you reach vertex C. From vertex C you reach vertex D. From vertex D you reach vertex E. So this particular path containing vertices A, B, C, D, E. So this is a path. Now let's see if it covers all the vertices of the graph. Yes, all the vertices of the graph have been covered in this path. Then let's see if the final and if the initial and final vertices are same. No, they are not same, and this is very compulsory for a Hamiltonian path. So clearly I can see that the starting vertex is A and the ending vertex is E, so they are not same. So these 3 points have been covered, and as I said that it is not necessary to cover all the edges of the graph. So all the edges have not been covered. You can see that the edge between vertex A and D has not been covered and the edge between vertex E and C has not been covered. Though if they were covered, even then there was no problem. But there is no rule on there is no compulsion on covering all the edges, but there is a compulsion on covering all the vertices. So clearly I can see that all the rules have been satisfied. The starting and ending vertices are different. All the vertices have been visited and no vertex has been visited more than once. So I can say that this graph contains a Hamiltonian path and the path is A, B, C, D, E. Right? Next, we will study Hamiltonian graph. A Hamiltonian graph is such a graph that contains Hamiltonian circuit. Fine. So, okay, whenever you find the Hamiltonian circuit in a graph, you can say such a graph is a Hamiltonian graph. But then, what is a Hamiltonian circuit? That means to study Hamiltonian graph, you have to study Hamiltonian circuit. So, a Hamiltonian circuit can be found by connecting the vertices in a graph so that the route traveled starts and ends at the same vertex. So, when I say you traverse the vertices of a connected graph. So first of all, the graph should be connected so that you can, starting from a particular vertex, you can reach any other vertex. So a graph should be connected for sure. Then it should be connected in such a manner that when we find a walk in the graph, the walk should have the starting vertex and the ending vertex as the same vertex. So in a Hamiltonian circuit, the starting and ending vertex are always same. Why? Because the name itself contains circuit. See, I said Hamiltonian circuit, and you know that a circuit is always a closed walk. And a closed walk is a walk in which the initial and final vertices are same. So when I say Hamiltonian circuit, it is quite obvious that it will have a walk in which the starting and ending vertices are always same. So no doubt about that. Also, all vertices must be visited once. You have to visit all the vertices of the graph once. So no vertex can be visited more than once, and all the vertices of the graph has to be visited. No vertex can be left. But not all edges need to be used. Again, the same rule does not apply for the edges. That means it is not necessary. So while finding such a closed walk, all the vertices need to be visited once, but not all edges need to be visited once. That is, in a simple language, you need to cover all the vertices of the graph, but you do not need to cover all the edges of the graph. So basically, I can say that a circuit in a connected graph is said to be Hamiltonian if it includes every vertex of the graph, and that too exactly once and no more than once, except of course the starting vertex and the ending vertex at which the walk terminates, because we are talking of a circuit, and obviously in a circuit the walk will terminate at and start at the same vertex. So a walk that includes every vertex of the graph exactly once and no more than once except the starting and ending vertex at which the walk would terminate is called a Hamiltonian circuit. Now let's find out a Hamiltonian circuit in this particular graph. So this is a graph which contains how many vertices? The number of vertices here are, in total I have 8 vertices, and my focus here is to cover all the vertices. Hence I am not counting the number of edges, because even if some few edges are left, that does not matter. If all of them are covered, good. Even if all are not covered, that would not affect. The only thing that matters is that all the vertices must be visited once. And here I can see that there are total 8 vertices in this graph. That means now a closed walk which I would find should contain all these 8 vertices. So I shall begin from vertex V1, travel along edge A and reach vertex V2. From vertex V2, I will travel along edge I, reach vertex V5. See, the directed arrows are showing you the direction of the walk. Then from vertex V5 I shall travel along edge F and reach vertex V8. From vertex V8 I shall travel along edge K and reach vertex V4. From vertex V4 I will travel along edge C and reach vertex V3. After reaching vertex V3 I shall travel along the edge V7. I shall travel along this particular edge called L. I shall travel along edge L and reach vertex V7. From V7 I shall travel along edge H and reach vertex V6. From vertex V6 I shall travel along edge I and finally reach vertex V1 again. So this can be depicted here, that this is my walk containing the alternating sequence of edges and vertices, wherein the starting vertex and the ending vertex are same. In between there are all the vertices which are present are those which are not visited more than once. Of course, if I'm talking of a walk, closed walk, I cannot apply this compulsion on the starting and final vertices, because in a closed walk the starting and final vertices will be repeated for sure. But other than that, all the other vertices in between, you can clearly see that none of the vertex has been repeated in this walk, plus all the vertices of the graph have been visited once, right? So my walk starts at V1 A, V2 I, V5 F, V8 K, V4 C, V3 C, V3. Then from V3 it goes to edge L, then V7 H, V6 I, V1. So my walk starts at this particular vertex V1, ends at the same vertex V1, so it is a closed walk for sure. Then all the vertices of the graph have been covered. In total I have 8 vertices. So 1, 2, 3, 4, 5, 6, 7, 8. All the 8 vertices have been visited. The last vertex I did not count because the starting and the ending vertex are same. So all the vertices have been visited. It is a closed walk and none of the vertex other than the starting and ending vertex have been repeated. So I can say that this is a Hamiltonian circuit. And any such graph, as I told you, that contains a Hamiltonian circuit is called a Hamiltonian graph. So today we have studied Hamiltonian path, Hamiltonian circuit and a Hamiltonian graph. The only difference between a Hamiltonian path and a Hamiltonian circuit is that a Hamiltonian path consists of an open walk and a Hamiltonian circuit consists of a closed walk. Other than that, all the conditions are same.